Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about solving systems of three equations with elimination.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. Negative x minus 5y minus 5z equals 2. 4x minus 5y plus 4z equals 19. And x plus 5y minus z equals a negative 20. And we need to solve this using elimination. First thing I'm looking for, I'm trying to find two equations easily that I can just add and eliminate a variable, and hopefully two variables. So what I see here is the first equation and the last equation, first and last equation here, I can add them together. So I'm going to put that over here, negative x minus 5y minus 5z, and it's important to take your time here, equals 2. The second equation, we have x plus 5y minus z equals a negative 20. And so I picked those equations because I noticed if I add them together, our 5y's will cancel, the variable y, as well as the x's. So I'm going to add it here, and let's go down. Negative x plus x becomes 0. They cancel each other out. Negative 5y plus 5y cancel each other out. Off to a good start. Negative 5z plus a negative z is a negative 6z. And then 20 plus negative 20 plus 2, negative 18. We divide both sides by negative 6, and z equals, well, a positive 3. So we now have one answer here, one variable we have found. We need to find another one. So where can we actually go, well, from here? We can take two other equations and see if we can eliminate something to maybe get a variable by itself. Okay? So we have z equals 3, but if I look at the second equation and the third equation, if I add them together, my y's will cancel. And I'd be left with an x and z, but I already know one of the z values. So that's what we're going to do. I'm going to take these two equations and actually, so this is just these two right here, I'll just add it here. Okay? So just to kind of save some space. 4x plus x is a good old 5x. Negative 5y plus 5y is, well, 0. That's what we're looking for. And then 4z plus a negative z is a 3z. And then 19 plus a negative 20 is a negative 1. And now, where do we know? Well, we know z is 3. So we're going to take that 3 value and put it in for z. So we have 5x plus 3 times 3 equals a negative 1. So let's solve that. Well, now we can solve for x, right? 3 times 3 is 9. We have 5x comes down. Subtract 9 to both sides, and 5x equals a negative 10. Divide both sides by 5, and x equals a negative 2. So now we have the x value, and we have the z value. Let's go find the y value. I can pick any one of my equations here to plug in a z and x value, and I think the last one's the easiest. So I'm going to take that equation, I'll put it right here. We have x plus 5y minus z equals negative 20. So you kind of see that's where I'm getting it from. Let's go plug in the values that we know. X we said was negative 2. We don't know the y value yet, we're going to find that. And then we're minus z being 3. And that's a negative 20. And now we have enough information to solve for y. Let's combine our like terms here. So negative 2 plus a negative 3 is a negative 5. So we have 5y minus 5 equals negative 20. We add a 5 to both sides, and we have 5y equals a negative 15. And divide both sides by 5, y is by itself, and that's a negative 3. So we have our three values. We can write it as in one statement here, negative 2, comma, negative 3, comma, 3. And there we have it. Our x value is negative 2, our y value is negative 3, and our z value is a positive 3, and that is our final answer. We're given this problem right here. Negative 4x minus 5y minus z equals 18. Negative 2x minus 5y minus 2z equals 12. And negative 2x plus 5y plus 2z equals 4. And we need to solve this by elimination. So the goal here, I'm trying to find two equations that when I add them together, they can eliminate some variables. And I look at the second two equations. All right. I know if I add them together, I can eliminate a variable. So let's go rewrite this and we'll see that out. Negative 2x minus 5y minus 2z equals 12. Negative 2x plus 5y plus 2z equals 4. Okay? So when we add these together, what do we notice is going to happen? Well, I can see that the 5y's will cancel. Negative 5y plus 5y is just a 0. And negative 2z plus 2z also cancels. And this is pretty cool with this equation that two variables will cancel. So when we add them together, we know that's going to cancel each other, and this will cancel each other out. And we're left with negative 2x plus a negative 2x, which is a negative 4x. And then 12 plus 4 is 16. Well, divide 4 to both sides, and x is by itself, or negative 4 to both sides. And we have 16 divided by negative 4 is a negative 4. And so we actually very quickly, by elimination, found one of our answers, x equals to negative 4. So now we have to combine two other equations, again, see what we can do and get another variable to eliminate. If we could deal with the first equation and the last equation, yeah. So we rewrite that here. Let me put a little line here, a little box. We rewrite the first equation, negative 4x minus 5y minus z equals 18. And the last equation, negative 2x plus 5y plus 2z, and that equals 4. If we add these two equations, what will get eliminated? Well, again, the 5y gets eliminated. We can see that here. So negative 5y and positive 5y, but not much else, right? So if we add it, negative 4x and negative 2x is a negative 6x. And then negative z plus 2z is plus 1z. 1z. 18 plus 4 is 22. But we found a value for x to be negative 4. If we put that in for this x right here, we have negative 4 here, then we add a z equals 22. And now we have an equation that's just one variable. We can solve for that variable. Negative 6 times negative 4 is a positive 24. Plus z equals 22. Subtract 24 to both sides, and z is now by itself, and 22 minus 24 is a negative 2. So now we have two of our values. Z is negative 2 and x is negative 4. We need to find the y. So we can pick any equation that we want here. I try to find one that might be easier, but we're going to plug in the z and the x value to get y. So let's go deal with this last equation right here. Negative 2, and instead of x, I'm going to put a negative 4 in, plus 5y, we don't know the y, we're going to find that one, plus 2 times the z value, which is negative 2. And that's equal to 4. So let's go solve for y now. Negative 2 times negative 4, positive 8, plus 5y, and then 2 times negative 2 is a negative 4, and plus a negative 4 equals 4. Combine our like terms, 8 plus negative 4 is a positive 4, so we have 5y plus 4 equals 4. Subtract 4 to both sides, 5y equals 0, and divide both sides by 5, and y equals 5. So we actually have the answers for each one of our variables. We can write it as a single statement, negative 4 for the x, 5 for the y, almost messed up there. If you caught that, see, that's what happens sometimes, you get ahead of yourself. Good thing I caught it. If you caught it, let me know down in the comment section below. But you divide 5 to both sides, that's still 0. Ooh, I almost made a common mistake, so gotta catch yourself. Y is 0 here, and then the z value is negative 2. So we can write this as one statement of negative 4, 0, negative 2 to represent the values for x, y, and z, and that is our final answer. We're given this problem right here. Negative x minus 5y plus z equals 17. Negative 5x minus 5y plus 5z equals 5. 2x plus 5y minus 3z equals a negative 10. And we need to solve this by elimination. So where can we go from here? Well, we try to find two equations that when we add them together, we can eliminate a variable. So if I look at my first equation and my last equation, let's rewrite that here. Negative x minus 5y plus a z equals 17. And then 2x plus 5y minus 3z equals a negative 10. I'm going to add these two equations together and, well, some variable will be eliminated. That variable is the y. You can see negative 5y plus 5y eliminates, and that cancels out to get 0. So let's add the other parts. Negative x plus 2x is a positive 1x. Z plus a negative 3z is a minus a 2z. And 17 plus a negative 10 is a positive 7. But right now, we still have an equation with two variables. So we have to do elimination again. Well, let's go find two equations that we can eliminate. Let's go with, what do I have here? We see the second equation and the third equation here. Again, we'll eliminate the y value. Right? We see the negative 5y and plus 5y. So let's rewrite that here. Negative 5x minus 5y plus 5z equals 5. And 2x plus 5y minus 3z equals a negative 10. And now we want to add these two equations together. Again, the y's will cancel. Negative 5x plus 2x is a negative 3x. And 5z plus a negative 3z is a positive 2z. 5 plus a negative 10 is a negative 5. So look, now we have two equations. X minus 2z equals 7, and negative 3x plus 2z equals negative 5. We can actually add these two equations together. So I'm going to put a little box around it just so we can see where they're coming from a little better. I'm going to rewrite them over here. X minus 2z equals 7, and negative 3x plus 2z equals a negative 5. And look at that. If we add these two equations, 2z's will be eliminated. Negative 2z plus 2z is just a 0. So x plus a negative 3x is a negative 2x. 7 plus a negative 5 is 2, positive 2. Then from there we divide both sides by a negative 2. X by itself here is, well, a negative 1. 2 divided by negative 2 is a negative 1. Alright, all that to just get x equals negative 1. So let's keep on going and we're going to try to see what we can do to get a z value. Well, lucky for us, this equation right here, we have, well, x already by itself, right? Sorry, we have x and a z, we can plug in a negative 1 in for x. So let's do that. Negative 3 times a negative 1 plus 2z equals a negative 5. And now we can solve for z. Negative 3 times negative 1, positive 3, plus 2z equals a negative 5. Subtract 3 to both sides, and we have, well, 2z equals, well, negative 5 minus 3, so negative 8. And divide both sides by 2, and z equals a negative 4. So we have z equals negative 4 now, and x equals a negative 1. We now have to, well, get our y. We pick an equation, and we plug in the z and x for it. So the equation I picked, I think what I thought was easiest was maybe the first equation, yeah. So let's rewrite that first equation, negative, and then instead of x, I'm going to put a negative 1 in. Minus 5y plus z, negative 4, and that equals 17. And again, you can pick any one of these three equations to do this with. I just picked the first one. Now let's simplify and solve for y. Negative 1 times a negative 1, or negative times negative 1 is a positive 1. Minus 5y minus 4 equals 17. 1 minus a 4 is, well, that's a negative 3. 5y minus 3 equals 17. Add 3 to both sides. 5y, oh, it's a negative 5y. Ooh, almost forgot that. Negative 5y equals, well, that would change the whole answer around. Equals, add a 3 to both sides, and we have positive 20. Divide both sides by a negative 5, and y equals negative 4. You gotta be careful there. So we have our x, y, and z value. We can write this as a point of negative 1, comma, negative 4, comma, negative 4. And that is, after all that, our final answer. We're given this problem right here. 4x plus 4y plus z equals 24. 2x minus 4y plus z equals 0. And 5x minus 4y minus 5z equals 12. And we want to solve this by elimination. We want to find two equations that when we add them together, some variable eliminates. I can see my first two equations, we can do that. If we rewrite this, 4x plus 4y plus z equals a 24. And the second equation, 2x minus 4y plus z equals 0. And from here, right, what we can see is, well, we can add the two values here to eliminate the variable y. 4y plus, or positive 4y minus 4y gives me 0. So they eliminate, hence the method, and we add the rest. So we have 4x plus 2x, which is a 6x, and a z plus z is a 2z. 24 plus 0, well, 24. Not too bad. All right, but we have two variables here. So we'll see if we can take two other equations and we can eliminate them to get, again, another variable gone. Well, if I look at the first equation and the last equation, okay, we can eliminate a variable, the y's. And that's cool. You want the same variable to be eliminated as well. So let's rewrite that here. 4x plus 4y plus z equals a 24. And the last equation, 5x minus 4y minus 5z equals a 12. I add these two equations together and look what eliminates. Again, the y. And that was by design. That's why we chose those two equations. Add it together. 4x plus 5x is a 9x. Z plus a negative 5z is a negative 4z. And 24 plus a 12 is a 36. So now we have two equations here that each has an x and each has a y, and we can really try to eliminate that, okay? Or find a way to eliminate a variable. I'm looking at my z's. We have a negative 4z here and a positive 2z. If I multiply this equation right here all by 2, right, I'd have a 12x plus a 4z equals a 48. I then can bring this equation over underneath it, 9x minus 4z equals a 36. So this equation here is the same as this one, just adapted a little, multiplied everything by 2, which is legal in mathematics. That allows us now to eliminate the z. We add together, the z's cancel, and we're left with 12x plus a 9x is 21x equals 48 plus 36, which is an 84. Divide both sides by 21, and x equals just positive 4. So all that work just to get one variable. Where can we go from here? We want to take an equation that's kind of easy to work with, and we can plug a 4 in to get another variable out. And I see the z, this one here, 6x plus 2z equals 24. So I'm going to rewrite that up here, and we're going to put x in for 4. We have 6 times 4 plus 2z equals 24. And now we can solve for z. 6 times 4 is a 24. And we have, again, the 2z right here equals 24. Subtract the 24 to both sides, and 2z equals, well, 0. Divide both sides by 2, and z equals 0. And we have a second value now that we have found. So we have an x, and we have a z value. We need to find a y value. So we take one of our equations, and we're going to plug in x and z for our variables. I picked here the second equation. Okay, so let's go rewrite that second equation here, but instead of x, so that one right here, instead of x, I'm putting a 4. And then we have minus 4y plus, and instead of z, I'll put a 0. And then we have 0 at the end. And now we have to solve for y. Well, it's not too bad. 2 times 4 is a 8 minus 4y equals, well, don't need the 0, 0. Subtracting 8 to both sides, you have negative 4y equals a negative 8. Divide both sides by a negative 4, and y equals a positive 2. And so we have our y value now, so we have everything. We write as a coordinate point, 4, 2, 0, and that's our solution. X is 4, y is 2, and z is 0, and that's our final answer. We're given this problem right here. 4r minus 4s plus 4t equals a negative 4. 4r plus s minus 2t equals 5. And negative 3r minus 3s, minus 4t equals negative 16, and we need to solve this by elimination. Well, my first goal is to try to find two equations that when I add them together will eliminate a variable. Let's look at the first equation and the last equation. Let's rewrite that here. 4r minus 4s plus 4t equals a negative 4. So the last equation, negative 3r minus 3s minus 4t equals a negative 16. Well, what happens when I add these two equations together? What variable is going to eliminate? And that's going to be the t's. The t's will cancel out. So 4t plus a negative 4t is 0t. Let's add the rest. 4r plus a negative 3r is a 1r. Negative 4s plus a negative 3s is a negative 7s. And negative 4 plus a negative 16 is a negative 20. Alright, so what else can we do? Well, I don't really see another way I can add two equations right away that t is eliminated. But I can adapt some equations here. So if we look at our first equation, if I rewrite that here, 4r minus 4s plus 4t equals a negative 4. If I take this, the second equation here, and I multiply everything by 2, if it's on there, there's a 2 there if it's off the screen. 2, if I multiply everything by 2, what do I have? I'm going to put it down here. We have an 8r plus 2s minus 4t equals a positive 10. And we can see now by doing that, we can eliminate the t value, or t variable. So 4t's will cancel there, we add them together, and we have a 12r, then negative 4s plus 2s is a negative 2s, equals negative 4 plus 10, which is a positive 6. Alright, so now we have 12r minus 2s equals 6, and we have r minus 7s equals negative 20. I directly can't add them together to eliminate anything. But let's rewrite this first one here. 12r minus 2s equals 6. If I take this equation as well, and I multiply it by 12, I now have something that, well, resembles, let's see. 12 times r is a 12r. 12 times the negative 7 is a negative 84 s equals, and then 12 times a negative 20 is negative 240. If we subtract the two, okay, we subtract the two equations, okay, so here I'm going to subtract them like this. Make sure we distribute the minus sign here. 12r minus a 12r is a 0. Fantastic. They cancel. Negative 2s minus a negative 84s is a positive 82s. 6 minus a negative 24 is 240, sorry, is like adding a 240, so we have 246. Divide both sides by 82, and after all that, s is by itself, and that's 3. So we have s is equal to 3 here. Alright, well what about the next variables? Where can we go from there? Well, we can take that s value, right, and we have this equation right here. R minus 7, and instead of s, we have a 3. And that equals a negative 20. So that's this right here. And now we can use that to solve, well, for r. 7 times 3 is 21, equals negative 20. Add a 21 to both sides, and r equals a positive 1. So we have an r value of 1, an s value of 3. We can take both of those and try to find our t value. Okay, so we take an equation, and what equation do I pick? I believe I picked, what is it? The second equation right here. So by picking that second equation, I have 4, and instead of r, I'm going to put a 1, we found, plus s, which is 3, minus 2t equals 5. And now, using that, we can solve for t. 4 times 1 is, well, 4, plus 3 minus 2t equals 5. 4 plus 3 is 7, minus 2t equals 5. Subtract a 7 to both sides. Negative 2t equals 5 minus 7 is a negative 2. Divide both sides by negative 2, and t is by itself here, and that's a positive 1. So we can write this as a coordinate point of r being 1, s 3, and t 1, and it's the order they gave us in the variables here. That's our final answer. R is equal to 1, s is equal to 3, and t is equal to 1. We're given this problem right here. X minus 6y plus 4z equals a negative 12. X plus y minus 4z equals 12. 2x plus 2y plus 5z equals negative 15. And we need to solve this system by elimination. Well, let's look at our first equation and our second equation. If I rewrite them here, we have x minus 6y plus 4z equals a negative 12. And then we have x plus y minus 4z equals a positive 12. If I subtract the two equations, so this whole second equation we're subtracting, we can eliminate the x variable. X minus 1x, right, is just 0. They cancel out. Negative 6 minus 1y is a negative 7y. 4z minus a negative 4z is like adding a 4z, so that's an 8z. And negative 12 minus 12 is a negative 24. All right, so we have one equation, we've eliminated a variable, we gotta do some more work. Let's go look at, well, this equation and this one here, the second and the third one. If I multiply this equation here by 2, the whole thing, we would have, both of them have 2 x's there. So let's do that. So I multiply this whole thing by 2 here, and we're left with 2x plus a 2y minus an 8z equals a positive 24. Bring down the third equation here, just 2x plus 2y, plus 5z equals a negative 15. By adding the two equations together, or sorry, subtracting, don't add, we gotta subtract. Adding won't do anything. Gotta subtract them here. So by subtracting these two equations, our x's are going to cancel. 2x minus 2x is 0x. But also look what happens with the y. 2y minus 2y also cancels. This is like a double impact great thing. Negative 8z minus 5z is a negative 13z. And then 24 minus a negative 15 is like adding a 15. It's 39. Divide both sides by negative 13, and z equals a negative 3. Great, we have one of our values. Well, look at this. Z is negative 3. If you plug it into this equation right here, for that z, we get y by itself. Or we can get y by itself. So let's do that. Negative 7y plus 8 times a negative 3 equals a negative 24. Let's keep going from here. Let's keep the negative 7y here. 8 times the negative 3 is a negative 24 equals a negative 24. Add 24 to both sides, and that's, well, 0. Negative 7y equals 0. Divide both sides by negative 7, and y equals 0. So now we have z equals negative 3, y equals 0. Let's go solve for x. Well, we pick one of our equations that we think is maybe easiest and substitute z and y in for, or the values in for their variables. And I picked the second equation. So we have x, so we're using this one again. I'm going to keep using the second equation a lot here. X plus, and instead of y, I'm putting a 0 in. Minus, for z, instead of z, put a negative 3 in. And that's equal to a positive 12. So now let's solve for x. Well, 0 we don't really need, right? Adding a 0 doesn't do anything. And negative 4 times a negative 3, that's a positive 12, equals 12. Well, I subtract 12 to both sides, and x equals 0. So we have our three answers. We can write it as a coordinate point. X is 0, y is 0, and z is negative 3. So there, again, is our final answer. 0, 0, negative 3. We're given this problem right here. X minus y minus 2z equals negative 6. 3x plus 2y equals a negative 25. And negative 4x plus y minus z equals 12, and we need to solve this by elimination. Well, I'm looking at here and trying to see what I can eliminate. The first equation here has a negative 2z, and then the third equation has a 1z. So if I multiply a second equation by 2, I can get something that can eliminate the z values. So let's rewrite this here, the first equation. X minus y minus 2z equals a negative 6. The second or third equation, I'm going to multiply this whole thing by 2 up here. 2 times negative 4x is a negative 8x. 2 times y is, well, 2y. And then 2 times negative z, negative 2z. And then don't forget the 12 times 2 is 24. If I subtract these two equations from each other, my z's will be eliminated. So let's do that. X minus a negative 8x is like adding a positive 8x, and we have 9x. Negative y minus 2y, right, is a negative, we have 3y here. Negative 2z minus a negative 2z is like adding a 2z's. 2z's cancel. And then negative 6 minus 24 is a negative 30. All right, so now I'm also in a pickle here because I have a 9x minus 3y equals negative 30, and I want to try to eliminate another variable. But what happens if I, well, take this second equation here and multiply it by 3? I would then have a 9x, which I have a 9x here. So let's go do that. All right, I'm going to take this second equation and the whole thing I'm going to multiply it by 3 and put that down here. We have a 9x now plus 3 times 2 is 6y equals, and then negative 25 times 3 is a negative 75. Let's rewrite this equation underneath it. 9x minus 3y equals a negative 30. And let's subtract these two equations. 9x minus 9x cancels. That was the whole point, right? They cancel each other out, and we get a 0. 6y minus a negative 3y is like adding a 3y, and we have a 9y. Negative 75 minus a negative 30, adding a 30, is a negative 45. Divide both sides by 9, and y is by itself, and it's a negative 5. All that, and we got y equals negative 5. Great. So where do we go from here? We can take one of our equations, and we can plug negative 5 in for y and solve for x. So let's go do that with this equation right here. We have 9x minus 3 times a negative 5 equals negative 30. Well, let's simplify and solve for x. 9x here. Negative 3 times a negative 5 is a positive 15 equals negative 30. Subtract a 15 to both sides. And we have 9x here equals a negative 30 minus 15, which is a negative 45. Divide both sides by 9. Oops, I almost wrote a 9 there. Let's make it an x. Divide both sides by 9. X is by itself here. And negative 45 divided by 9 is a negative 5. So we have we got x value and a y value. We need to find the z value. So if I use my first equation here, I'm going to substitute, substitute our x and y values, variables, in for their numbers. So instead of x, I have a negative 5 from the first equation again, minus, in parentheses, negative 5 here, minus 2z equals a negative 6. And now we're solving for z. Negative 5 minus a negative 5 is like, minus negative 5 is like adding a positive 5, and that actually comes out to be 0. They cancel each other out, right? That's positive, 0. So we have minus a 2z here equals negative 6. Divide both sides by negative 2, and z is by itself. Negative 6 divided by negative 2 is a positive 3. So we have our three values. We can write as a coordinate point. Negative 5 for x, negative 5 for y, and z is 3. And that is our final answer. X is negative 5, y is negative 5, and z is 3. We're given this problem right here. 5a plus 5b plus 5c equals negative 20. 4a plus 3b plus 3c equals a negative 6. And negative 4a plus 3b plus 3c equals 9. And we need to solve this system by elimination. Well, first thing I'm going to do is, I see two equations I can add together that will eliminate a variable. All right? I see this first, the second one, and the third one. So let's go rewrite that here. We have 4a plus a 3b plus a 3c equals a negative 6. And then the second one, negative 4a plus 3b plus 3c equals a 9. If I add these two equations right off the bat, and we're going to add them together, a's are going to cancel. 4a plus a negative 4a cancels out. So then 3b plus 3b is a 6b, and 3c plus a 3c is a 6c as well. And that's equal to, well, negative 6 plus 9 is a positive 3. All right. Well, what happens now, let's see if we can eliminate another variable. If I take my first equation and I multiply it by, well, 4, what do I get? 4 times 5a is a 20a, so right here. 4 times 5b is a 20b. We have 20c again, and then 4 times negative 20 is a negative 80. If I take my second equation here and I multiply that by 5, look what happens. 5 times 4a is a 20a. 5 times 3b is a 15b. 5 times 3c is a 15c. And 5 times negative 6, negative 30. And in doing so, I kind of set these things up where if I subtract the equations here, the variable a will get eliminated again. So 20a minus 20a cancels out at 0. 20b minus 15b is a 5b. And then 20c minus a 15c is again a 5c. And, well, what does that equal? Negative 80 minus a negative 30 is like adding a positive 30, negative 50 here. Okay? Well, there's two equations here, and we want to bring them together to see if we can eliminate something. So we can either multiply it by a value or add it, divide by something, and see if we get the variables to cancel. If I divide actually this whole thing by 5 here, I'm left with, right, I can divide the whole thing by 5. B plus C equals a negative 10. Great. Why don't I divide this whole thing by 6? 6 is canceled. We have, well, B plus C equals a 1/2. Great. Let's bring this equation over here. We bring a B plus C equals a negative 10. And let's subtract these two equations here. Well, by doing so, our B values cancel. B minus B is 0. And C minus C is also 0. So we have 0 on the left-hand side. That's weird. The variables all cancel. On the right-hand side, 1/2 minus a negative 10, or adding a positive 10, is going to be like, well, so 1/2 minus a negative, adding a positive, that's 10 and 1/2. What does 0 equal 10 and 1/2? Well, no. So it's a weird thing here. Two variables canceled, and we got something that wasn't really true. So what does that mean? That means for this problem, we have no unique solution. Meaning that there's no one unique solution that makes this whole thing true. So our final answer here, kind of a little different, is no unique solution. We're given this problem right here. Negative 6r plus 5s plus 2t equals negative 11. Negative 2r plus 1s plus 4t equals negative 9. And 4r minus 5s plus 5t equals a negative 4. And we need to solve this by elimination. Let's rewrite our first equation here. Negative 6r plus 5s plus 5s, there we go, plus 2t equals negative 11. If we take the second equation and we multiply the whole thing by 3, what do we get? Well, 3 times negative 2r is a negative 6r. 3 times s is a 3s. 3 times 4t is a 12t. And, well, 3 times negative 9, negative 27. If we subtract these two equations now, or we're subtracting the whole thing, our r is going to cancel. Negative 6r minus a negative 6r is like adding a 6r. They cancel. And so that's kind of the goal. We're trying to get rid of a variable here. 5s minus 3s is a 2s. And then 2t minus a 12t is a negative 10t. And then negative 11 minus a negative 27 is like adding a 27. That's a positive 16. All right. Well, now I'm going to try to eliminate another variable. The second equation is going to be useful again. If we multiply the second equation by 2, what do we get? We have a negative 4r here plus a 2s. So make sure I follow my steps here. Plus 2 times 4t is an 8t. And then don't forget 2 times negative 9, negative 18. Bring down the second equation here, or third equation, sorry. 4r minus 5s plus 5t equals negative 4. And look, we have it set up now where our r's will cancel. We add the two equations. Negative 4r plus 4r is just 0. R cancels out. 2s plus a negative 5s is a negative 3s. And 8t plus a 5t is 13t. Negative 18 plus a negative 4 is a negative 22. All right. So then from here, where do we go? Well, these two equations, right away, if I add them together, I can't eliminate anything, but I can adapt them. So if we take this second, or this equation right here, what happens if we multiply it by a 2? In doing so, we have a, well, negative 2 times negative 3 is a negative 6s. 2 times 13 is a 26t. And then 2 times negative 22 is a negative 44. This equation here, what happens if we multiply it by a 3? The whole thing comes down here. 3 times 2s is a 6s. 3 times negative 10 is a negative 30t. And then 3 times 16 comes out to be a 48. If we add these two equations together, what happens? Well, these s's cancel. Negative 6s plus 6s cancels. 26t plus a negative 30t is a negative 4t. And negative 44 plus 48 is a positive 4. Divide both sides by negative 4, and t equals a negative 1. So all that work, we got one value. T is negative 1. So where can we go from here now to solve, well, for our other values? If we look at this equation right here, the 2s minus 10, right, plus a negative 10, but minus 10, and instead of t, I put a negative 1 in, we substitute that in, equals 16, we now just have the variable s in this equation, so we can solve for that. 2s comes down, negative 10 times a negative 1 is a positive 10, equals 16. Subtract 10 to both sides, 2s equals a 6. Divide both sides by 2, and s equals 6 divided by 2, which is 3. So we have s equals 3, t equals negative 1. We can solve now for r. We either pick an equation and we're going to plug in t and s for our variables there, or the values they have. So the equation I picked was the last equation here. The last one. So the last equation here, I'll put 4r minus 5, and instead of s, I'm going to put a 3, that value here, plus 5, and instead of t, I put a negative 1, equals negative 4. Now we're going to solve for r. Okay? So we have 4r here. 5 times 3 is a negative 15. And then 5 times negative 1 is a negative 5, equals negative 4. 4r comes down. Negative 15 minus 5 is a negative 20, equals negative 4. Add a 20 to both sides. 4r equals 16, positive 16. Divide both sides by 4, and r is by itself, and that's equal to 4. So we have our r, our s, and t value. We can write as a coordinate point to be 4, 3, negative 1 in the order they give it to us. And so our final answer here is r is 4, s is 3, and t is negative 1. We're given this problem right here. Negative 6x minus 2y plus 2z equals negative 8. 3x minus 2y minus 4z equals 8. 6x minus 2y minus 6z equals a negative 18. And we need to solve this system by elimination. Well, let's look at our first two equations. If I rewrite them here, negative 6x minus 2y plus 2z equals a negative 8, and 3x minus 2y minus 4z equals a positive 8. We can see that if I subtract the two equations here, our y value will be eliminated. Negative 6x minus 3y is a negative 9x. But negative 2y minus a negative 2y is like adding a positive 2y. They cancel. 2z minus a negative 4z is like adding a 4z. So it's a 6z here. And negative 8 minus an 8 is a negative 16. So great. We eliminated this and eliminated the variable y. So let's do the same thing and see if we can adapt something else to eliminate y again. And actually the second two equations we can do that. So let's rewrite them. 3x minus 2y minus 4z equals 8, and 6x minus 2y minus 6z equals a negative 18. If we subtract the two equations from each other, okay, we subtract them, well, what do we get? 3x minus 6x is, well, a negative 3x. But here, negative 2y minus a negative 2y is like adding a positive 2y, and they cancel out. Negative 4z minus a negative 6z is like adding a positive 6z, and we have plus 2z here. 8 minus a negative 18 is like adding a positive 18, and we have 26. So where can we go from, well, here? Well, I know I can eliminate. If I multiply the second equation by 3, I get negative 3x times 3 is a negative 9x. So let's do that. I'm going to take this whole thing, multiply it by 3, and put it up here. So 3 times negative 3 is a negative 9x. 3 times 2z is a 6z. And then 3 times 26 is a 78. All right. If I subtract these two equations here now, I can eliminate my x value. Negative 9x minus a negative 9x plus a positive 9x, they cancel. Now let's go with the z's. 6z minus a 6z, well, that's also 0. They cancel, so we have 0 on this side here. Negative 16 minus 78 is a negative 94. Well, does 0 equal negative 94? No, that is incorrect. So what happened here? Well, we have 0 not equal 94. That's not a true statement, and all of our variables cancel. So when this happens, we have no unique solution. Meaning there's no unique solution to this system of equations, and that is our final answer. But given this problem right here, 5x minus 4y plus 2z equals 21. Negative x minus 5y plus 6z equals a negative 24. Negative x minus 4y plus 5z equals a negative 21. And we need to solve the system by elimination. Well, if I look at my first two equations here, I can see I can get the x values to cancel if I have a 5x here. So if we rewrite our first equation, 5x minus 4y plus a 2z equals 21, and we take the second equation and multiply it by 5, right? So we take this whole equation and multiply it by 5 and put it over here. 5 times negative x is a negative 5x. 5 times negative 5y is a negative 25y. And 5 times 6z is a 30z. Equals 5 times a negative 24 is a negative 120. All right. Well, if I add these two equations together, we're going to eliminate the x variable, which is great. 5x plus a negative 5x, they cancel. Negative 4y minus 25y, or plus a negative 25y, is a negative 29y. 2z plus a 30z is a 32z. And 21 plus a negative 120 is a negative 99. So then from here, what else can we do? Well, these two equations, right, if we subtract them, we'll eliminate the x as well, which is great. So I'm going to rewrite that here so we have a little more space. Negative x minus 5y plus 6z equals negative 24. And negative x minus 4y plus 5z equals a negative 21. And I'm going to subtract the two equations. This leaves us with, well, the x values canceling, which is great. Negative x minus a negative x plus positive x, 0. Negative 5y minus a negative 4y, or adding a 4y, is a negative 1y. And then 6z minus 5z is, well, just plus 1z. Negative 24 minus a negative 21 is a negative 3. That's great. We have actually a pretty simple equation. If I multiply this, though, right, because I want to see if I can eliminate a variable here. So if I multiply it by a 29, this whole thing by a 29, and put it up here, what do we get? 29 times negative 29, or times a negative y, is a negative 29. Don't write it backwards. 9. Which is great. That's what we want to find, something to eliminate the y's. 29 times z is, well, 29z. Pretty easy here. This one's a little tricky. 29 times a negative 3 is a negative 87. Negative 87 here. If I subtract the two equations from each other, we will eliminate the y values. Negative 29 minus negative 29y is just 0. 32z minus a 29z is a positive 3z. Oh, this got simpler very quickly. And negative 99 minus a negative 87, or add an 87, is a negative 12. Divide both sides by 3, and z is by itself here, and that's equal to negative 4. We got one of the values, but it's actually not too hard now. We're going to take that z and, well, plug it in here. We have negative y plus a negative 4 equals negative 3. Let's solve for y. Add a 4 to both sides. We have negative y equals a positive, well, a positive 1. Divide both sides by negative 1, and y equals a negative 1. Okay, right there. So y equals negative 1, and we have z equals negative 4. We need to pick one of our equations, plug them in, to get our x value. And the equation I picked, which one did I pick here? Negative 21. This one. They all kind of blur together sometimes. So let's rewrite that equation right here. We have a negative x minus 4, and instead of y, put a negative 1. And then plus 5z. So plus 5, and z is negative 4. And that equals negative 21. We now need to solve for x. Oof, this is getting hairier and hairier here. Negative x comes down. Negative 4 times negative 1 is a positive 4. 5 times the negative 4 is a negative 20. Equals negative 21. Negative x comes down. Combine like terms. 4 minus 20, negative 16, equals negative 21. Add a 16 to both sides. And negative 21 plus 16 is negative 5. Divide both sides by negative 1. And x equals a positive 5. So if we want to write this now as a coordinate point, our x value is 5, y value is negative 1, and its z value is negative 4. And so our final answer here is x is 5, y is negative 1, and z is negative 4. We're given this problem right here. 6r minus s plus 3t equals a negative 9. 5r plus 5s minus 5t equals 20. And lastly, 3r minus s plus 4t equals negative 5. And we need to solve the system by elimination. Well, our first equation, if I rewrite it here, 6r minus s plus 3t equals negative 9. And I combine that, right, our third equation, sorry, as 3r minus s plus 4t equals negative 5. I picked these two because if I subtract the second one, we can see that we will eliminate the s variable, hence solve by elimination. So we get a new equation. What's that? 6r minus a 3r is, well, 3r. Negative s minus a negative s, adding a positive s, that was the whole point s's cancel. 3t minus 4t is a negative t. And negative 9 minus a negative 5, or adding a positive 5 to it, is a negative 4. So we have 3r minus t equals a negative 4 here. Well, we gotta find another equation here. A lot of times we multiply something here to cancel out, but we also can divide. And if we notice, we have 5s here and a single 1s right here. This second equation, if we divide by 5 or multiply by like a 1/5, a lot cancels out. So what happens when we do that? Well, 1/5 times 5r is just a 1r, or divide by 5, same thing. Divide this by 5 and we have just an s. Divide this one by 5, we have a t, a minus a t, and then 20 divided by 5 is a 4. That's a much simpler looking equation. We bring down the third equation here, 3r minus an s, so minus an s here, plus 4t equals negative 5, and look, we add them together and we will eliminate the s's. So it's kind of tricky here. R plus 3r is a 4r, the s's cancel when we add them together, and negative t plus 4t is a positive 3t. And then 4 added to negative 5 is a negative 1. Okay? Now we have 4r plus 3t equals negative 1. Well, how can I maybe combine these two to eliminate a variable? This equation here, if I multiply it by 3, I have negative 3t and positive 3t here. They would cancel. So to multiply it by 3, I get a 9r here minus 3t equals a negative 12. Bring this equation over here. We have 4r plus 3t equals a negative 1. Now if we add these two equations, we have 9r plus 4r is 13r. The t's cancel. Negative 3t plus 3t is just 0. And that equals, well, negative 12 plus a negative 1, negative 13. Divide both sides by 13, and r equals a negative 1. So we have r equals a negative 1 here. Well, what can we do with that? We need to get another variable. We'll solve for another variable, all right? Well, where am I? Which one am I going to pick here? I gotta see. Oh, right here. I can plug that r equals negative 1 to get my t value. All right, so I'm going to do that. Take this equation here, 4 times negative 1 plus 3t equals a negative 1, and we can solve for t. 4 times negative 1 is negative 4, plus 3t equals negative 1. Add a 4 to both sides, 3t equals a positive, well, negative 1 plus a 4 is a positive 3. Divide both sides by 3, and t equals 1. So t equals 1 right there, and r equals negative 1. So what we have to do now is pick one of our equations, okay, and solve, well, for the last missing variable there to get, what is it, s, we haven't found yet, okay? So we pick one of our equations, and I think this is the easier one, the bottom one. So we have 3, and instead of r, I'll pick a negative 1, plus, or minus, sorry, whoops, it's a minus an s value. So we minus the s value, which we don't know. We'll take our time here, so I'll mess up here. And then 4 times our t value, which we found to be a positive 1. And that equals a negative 5. And so now we can solve this, well, for s. 3 times negative 1 is a negative 3, minus s, and 4 times 1 is 4, equals negative 5. Negative 3 plus 4 is a positive 1, so negative s plus 1 equals negative 5. Subtract 1 to both sides, and we have negative s equals a negative 6. Divide both sides by negative 1, and s equals a positive 6. And so we have our r, our s value, and our t value. We can write as a coordinate point as negative 1, comma 6 in the order they give it to us, comma positive 1 for the t. And so our final answer here is r equals negative 1. What's the next one? S is 6, and t is a positive 1. We're given this problem right here, Negative 3a minus b minus 3c equals a negative 8. Negative 5a plus 3b plus 6c equals negative 4. And negative 6a minus 4b plus c equals a negative 20. And we need to solve this by elimination. Well, I can see here, if I multiply the first equation by a negative 3 and bring the second equation, we will eliminate the a variable. So I'm going to take the top equation here, multiply by negative 2, not by negative 3, negative 2. So I multiply the first one by a negative 2, and we get that here, negative 2 times a negative 3a is a 6a. Negative 2 times a negative b is a positive 2b. Negative 2 times a negative 3c is a positive 6c. And negative 2 times a negative 8 is a positive 16. We bring down the third equation, just bring it over here. Negative 6a minus 4b plus c equals a negative 20. And now we want to add these two equations. We add them together, and well, what do we get? Well, 6a plus a negative 6a, they eliminate, hence the process. 2b plus a negative 4b is a negative 2b. 6c plus a c is a 7c. And 16 plus a negative 20 is a negative 4. All right, what else can we do here? All right, we got to find another equation. Let's try to eliminate an a again using two different equations. All right, well, what can we do here now? All right, if we take our first equation, right? If we take our first equation and we actually multiply that by a negative 5, that's in there, negative 5. We have a positive, 15a. Negative 5 times a negative b is a positive 5b. Negative 5 times a negative 3c is a positive 15c. And negative 5 times a negative 8 is a positive 40. Then, if we take the second equation and we multiply that by a 3, here, so this one came down here, and then this one's going to go down here. By 3, we'll get a negative 15a, and that's going to start canceling out the a's. So we have a negative 15a here, multiply the 3 across. We have 9b, and then 3 times 6 is 18. So we have an 18c equals, make sure I keep my spot, 3 times a negative 4, which is a negative 12. We now can add these two equations together. Oh, that's a b. The 15a's will eliminate. 5b plus 9b is a 14b. 15c plus 18c is a 33c. And 40 plus a negative 12 is a 28. All right, so now we have two equations here. Well, they're not exactly the same. We can't really eliminate a variable right off the bat. So we have to multiply something out here. All right. Well, if we multiply this equation by a 7, the whole thing, what do we get? Well, 7 times negative 2b is a negative 14b, and look, that's what I was trying to find the opposite of. We have 14b here. 12 parts, 7 times 7c is 49c, and 7 times a negative 4 is a negative 28. Bring this over here, and we have a 14b plus a 33c equals a positive 28. Now we can add the two equations. The b's cancel, perfect. 49c plus 33c is an 82c, okay? Equals, well, negative 28 plus 28 is just 0. They cancel each other out. Divide both sides by 82, and after all that, c is just equal to 0. All that work for that. Well, this actually makes it pretty easy. We take that c equals 0, plug it in here, and solve for b. 14b plus 33 times 0 equals 28. Well, 33 times 0 is 0. Perfect. 14b right here equals 28. Divide both sides by 14, and b equals a 2. So we have two values. We need to find a. So we either take any one of our original equations, and we're going to plug in 2 for b and 0 for c. Following my notes here, I used the first one. We take negative 3a minus our b value, which is 2. So we plug 2 in for b. Minus 3 times c, which is 0, equals negative 8. And we're going to solve for a. Well, negative 3a comes down. We have a minus 2 here. And negative 3 times 0 is just 0. And then equals negative 8. Add a 2 to both sides. And negative 3a equals, well, that's a negative 6. Divide both sides by negative 3. And a is a positive 2. And so we have our answers here. We can write as a coordinate point. A comes first, then b. So 2, 2. Then c value 0. And there we have our final answer. A is equal to 2, b is equal to 2, and c is equal to 0. We're given this problem right here. Negative 5x plus 3y plus 6z equals 4. Negative 3x plus y plus 5z equals a negative 5. Negative 4x plus 2y plus z equals 13. And we need to solve this system by elimination. The goal is to try to eliminate a variable. If we take our first equation, we see there's 3y here. If I have 3y in the denominator, or not denominator, second equation, we can subtract the 2 and the y's will get canceled. So let's go rewrite the first equation. Negative 5x plus 3y plus 6z equals 4. The second equation, I'm going to multiply the whole thing by a positive 3. In doing so, negative 3 times negative 3x is a negative 9x. 3 times y, 3y. 3 times 5z is 15z. Don't forget the end. 3 times negative 5, negative 15. I now can subtract the two equations, and our y's will be eliminated. Get the other parts. Negative 5x minus a negative 9x, which is adding a 9x, so that's a 4x. The y's cancel. 3y minus 3y eliminates. 6z minus 15z is a minus a 9z. And then 4 minus a negative 15, again, like adding a 15, is 19. All right, so we have one equation here now with an eliminated variable. How else can we do this to, let's say, eliminate, well, the y's? If we take this middle equation again, and we multiply it by 2, what do we get? Well, we have a negative 6x here, plus 2y, plus, well, 2 times 5 is 10, so we have 10z, equals, well, a negative 10, the negative 5 times 2. This third equation also has a 2y, and that's kind of why we did it. Let's bring it down, negative 4x plus 2y plus z equals 13. That'll bring it all down correctly. I did. So now we want to subtract these two equations, and that's going to eliminate the second y's here. Negative 6x minus a negative 4x. It's like adding a 4x, right? And we have a negative 2x here. 2y minus 2y, they're eliminated. 10z minus 1z is a plus a 9z. And negative 10 minus 13 is a negative 23. So now we have this equation and this equation both have the same variables, x and z. Well, actually, watch this. I just bring this over here, negative 2x plus 9z equals a negative 23. And if I add these two equations, our 9z's will cancel, which is great for us. So 4x plus a negative 2x is just a 2x here. Negative 9z plus 9z eliminates, we get 0. And then 19 plus a negative 23 is a negative 4. Divide both sides by 2, and x equals a negative 2. And that's our first value we're finding, or we found. So where can we use that? Well, in this equation right here, we just plug negative 2 in for x, and we can solve for z. So negative 2 times a negative 2, plug it in for x, plus 9z equals negative 23. And now we can solve for z. Negative 2 times negative 2 is a positive 4, plus 9z equals a negative 23. We bring the 4 over here, subtract 4 to both sides, and 9z equals, well, that's a negative 27. Divide both sides by 9, and we get z by itself is equal to negative 27 divided by 9, and negative 3. So we have x equals -2, z equals -3, and what we have to do now is pick one of our equations and plug these values in for their variables. Okay? So the equation I picked here was the last equation, and it really doesn't matter, it can be any of them. I'll just pick the last one here. So I'm going to rewrite the last equation, -4, but instead of x I put a -2. Then we have plus 2y plus z, we're going to put a -3 in, and that's equal to 13. Now we have an equation with one variable. Let's solve for y. -4 times -2 is a positive 8. 2y comes down, and we have a -3 equals 13. 8 minus 3 is a 5, so we have 2y here plus 5 equals 13. Subtract 5 to both sides, 2y equals 13 minus 5, which is 8. Divide both sides by 2, and y equals 8 divided by 2, which is 4. So we have our three values we can write as a coordinate point now, as -2 for the x, y is 4, and z is -3. And so our final answer here, make sure I have it right, which we're good. Our final answer is x is -2, y is 4, and z is -3. We're given this problem right here. 3a minus 3b plus 4c equals a -23. A plus 2b minus 3c equals 25. And 4a minus b plus c equals 25. And we want to solve this system by elimination. Well, first thing I'm looking at here is, I see a 3a and an a. If I multiply the second equation by 3, I will also have a 3a there, and I can eliminate the variable a. So let's first rewrite our first equation right here. 3a minus 3b plus 4c equals a -23. The second equation, if I multiply it by a 3, what do we get? 3 times a is 3a. 3 times 2b is a plus 6b. 3 times a minus 3c is minus 9c. And 3 times 25 is a 75. I now can subtract these two equations. By doing so, I will eliminate the variable a. 3a minus 3a, 0. Done. -3b minus a 6b is a -9b. And 4c minus a -9c is like adding a 9c. And we have a 13c here. -23 minus 75. Okay, -23 minus a 75, right? It's kind of like adding them together, so we have an 8 here. And then 3, 9 here, so we have a -98. So -23 minus 75 is a -98. Just double checking that. Yeah, okay. -98. So now what we gotta do is we'll try to see if we can get another way to eliminate a. Well, we have a here and 4a. So we take the, well, for second equation, if we multiply it by 4 here, we put it down there, what do we get? 4 times a is a 4a. 4 times 2b is a 8b plus 8b. And 4 times a -3c is a -12c. And that is equal to 4 times 25, which is 100. Bring down the second equation below it. 4a minus b plus c equals 25. And now we have to subtract the two equations. 4a minus 4a, well, it eliminates, is 0. That's what we're going for. 8b minus a -b is like adding a positive b, and that's 9b. -12c minus 1c is a -13c, and that's equal to 100 minus 25, and which is a 75 here. So now we have two equations here, and look, they both have a 9b and a -9b. So we bring this over here, we have 9b minus 13c equals -98, and we have a 75, oh sorry, 75 right here. Okay. So now, let's add these two equations together. -9b plus a 9b, well, it's 0b. 13c minus a 13c, again, is a 0. -98 plus a 75, how's that go? -98, it's almost like a 98 minus 75, but you know it's going to be negative. A minus 5 is 3, 2, 23. And it's a negative 23 there. Well, does 0 equal negative 23? No. 0 does not equal negative 23. So what does that mean in the context of this problem here? When this happens and you come up with something that's not equal to, if all the variables are eliminated, this is what happens. This is a no unique solution. Meaning, there's no unique solution to the system of equations. So that is our final answer. Final answer, no unique solution. We're given this problem right here. Negative 6x minus 2y minus z equals a negative 17. 5x plus y minus 6z equals 19. Negative 4x minus 6y minus 6z equals a negative 20. And we want to solve this by elimination. Well, what can we do? We want to find a way we can cancel out a variable. And if I take the second equation and multiply it by 2, we'll have 2y here, and then a negative 2y in the first equation, and 2y here will cancel. So let's rewrite the first equation, negative 6x minus 2y minus z equals negative 17. The second equation here, I'm going to multiply that by 2. What do we get? 2 times 5x is a 10x. 2 times y is, well, a 2y. 2 times negative 6z is a negative 12z. And 2 times 19 is a 38. I now can add these two equations and see what happens. Negative 6x plus 10x is a 4x. Negative 2y plus a 2y eliminates, and that's just a 0y. Negative z plus a negative 12 is a negative 13z. And negative 17 plus 38 is a positive 21. All right, what else can we do? Or what else can we do? If we take the, if we take this equation, or the first, what am I doing here? Make sure I have my right steps here. If I want to eliminate the y's here, okay, perfect. We have a negative 6y here, and we have a negative 2y here. If I take the top equation and multiply it by a 3, we would have a negative 6y up there, and that will help me eliminate that. So let's put that down here. 3 times negative 6 is a negative 18x. 3 times minus 2y is a minus 6y. And 3 times a minus 7 is a minus 3z. 3 times a negative 17 is a negative 51. Then we take the last equation and we're put it down here below it. We have a minus 4x minus 6y minus 6z equals a negative 20. I now can subtract, that's a 20, these two equations, and we'll eliminate that 6y. Negative 18x minus a negative 4x is like adding a 4x. We have a negative 14x here. Negative 6y minus a negative 6y is like adding a 6y. Cancel the 6y's out. Negative 3z minus a negative 6z is like adding a 6z, and we have 3z here left over. And then we have negative 51 minus a negative 20 is like adding a 20. It's a negative 31. All right, so now we have this equation that has x and z, and this equation has x and z. And we need to adapt them to find a way we can eliminate a variable. Well, I can see here if I take 14 times 2, I get 28, and 4 times 7, I get 28, and we can eliminate stuff there. So I'm going to take this equation here, multiply it by 2, and I'm left with a negative 28x plus a 6z equals a negative 62. And that multiply 2 is to all parts. This one here, I'm going to multiply it by a 7, and I'll put it down here. I multiply the whole thing by a 7. And 4 times 7 is a 28x. 7 times 13 is a 91, so we have negative 91z here. And that's equal to 7 times 21, which is a 147. I now can add these two equations together, and the x's eliminate. Negative 28x plus 28x is 0. 6z minus or plus a negative 91z is a negative 85z. Negative 62 plus 147 is an 85. Divide both sides by negative 85, and z equals a negative 1. So we have z equals -1 here. All right, well, what can I do now? I want to somehow get other variables. Well, if we take this equation right here and put z equals -1, and for the z value, drop the cap, oh well, -1 in for the z, I have x by itself. So we have 4 times x minus 13 times z, which is -1, equals a positive 21. 4x comes down, -13 times a -1 is a positive 13, equals 21. Subtract 13 to both sides, and we have 4x on the left, and on the right, 21 minus 13 is an 8. Divide both sides by 4, and x equals a positive 2. So now we have our z value, our x value. Let's find our y value. We can pick any equation we want and plug these values in and solve for y. Find one that you might think it's easy or how you're going to work with it, and let's just go with the last one here. So I'm going to pick this one here. We have a -4, and instead of x, I put a 2. Then we have minus 6y minus 6, and then times z, which is -1, and it's equal to -20. Let's simplify this out. -4 times 2 is -8, minus 6y, and then -6 times -1 is a positive 6, equals a -20. -8 plus 6 is a -2, so we have -6y minus 2 equals -20. Add a 2 to both sides. -6y equals a -18. Divide both sides by -6, and y is by itself, and it's equal to, well, a positive 3. We can write this as a coordinate point. X first is 2, y is 3, and z is -1. And so that's it. Our final answer here is x equals 2, y equals 3, and z equals a -1. We're given this critical thinking question here. Write a system of equations with the solution 2, 1, 0. There's actually many ways and many solutions to this answer. So you might come up with something a little different than what I have here. So the way I'm going to give you my process here. I start off with the variables x, y, z, these three. I say, okay, x is 2, y is 1, and z is 0. So if we have x plus y plus z is equal to, well, 2 plus 1 plus 0 is 3. We have one equation that works for the solution, but there's many solutions for that equation, for x, y, and z that work. So let's find another equation that also has 2, 1, and 0. If I have 2 times x plus y plus z, well, what does that equal? If x is 2, 2 times 2 is 4, plus 1y is 5, plus 0, being z, is still 5, and so we have 5 right there. We now have 2 equations that work for this solution, but we need to have 3 because we have 3 variables. So let's go with the third one. What if, well, we have 1x, and then instead of 2 x's, we have 2 y's. We have 2y, then, I don't know, minus a z. We're going to add a z, minus z, doesn't really matter because z is 0. Well, 2 plus 1, or sorry, 2 for x, 1 for y, that's also a 2. So we have 2 plus 2, which is 4, minus 0. What does that equal? That equals a 4. And now I have 3 equations that involve x, y, z, and I know I can solve them that will give us a solution. Again, there's many ways that you could do this. You could come up with different equations by the same process here. Just make sure that final number adds up right and you have a new equation. But there are 3 distinctly different equations here, and all of them have a solution of 2, 1, 0. So there we have our final answer. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math, when you need help you use Minute Math.